So Ken is the PI from our grant, and he's going to be doing the introduction today. We are just after 9 o'clock, and we had several people sign up. So we will get rolling, and I'm sure people will be joining us as they kind of add in. I've turned off the ding so it won't ding as people join us. But Savannah, I want to thank you for presenting today, and I'm going to turn it over to Ken to do the introductions. And if people have questions, please feel free to put them in the chat. And with that, I think we are good to go. You good, Ken?
Yeah, we're ready to roll.
All right. Well, all right. Thank you, everybody.
All right, so recording is rolling. Welcome, everybody, and thanks for joining us for the Create webinar series. Today we'll be hearing from Savannah Brown, who's going to talk to us about using NASA datasets in renewable energy courses. Before we launch into Savannah's presentations, just a few things to share with folks. First, of course, you can find our webinar schedule at the Create Energy Center, just createenergy.org. This is one of a series of webinars on integrating concepts into renewable energy instruction. So we invite all of you to check out our upcoming webinars there. Also, just a little bit of sort of housekeeping details. The chat window will be open. Once Savannah begins her presentation, we'll mute microphones and cameras just to make things go smooth. If you have questions along the way, please feel welcome to type them into the chat window, and I'll try and gather those while Savannah's presenting and synthesize them so that we can have some Q&A and discussion at the end of the presentation. So with that, let me introduce Savannah. She's a graduate of the Ohio State University, and this spring will be graduating from North Carolina State with a master's in STEM education. During her time at NC State, she's worked on industry immersion in the clean energy sector and connecting clean energy careers with classroom experiences. She has taught all levels of middle school science and currently teaches sixth grade science at Swansboro Middle School in North Carolina. And Savannah reports that she loves sharing her passion for science and the environment with so many kids every day. So with that, I will turn over the floor here to Savannah, and please take it away.
Thank you so much. I'm going to go ahead and share my screen. I wanted to give you a little more background on the work that I have done in the last couple of years. I was fortunate enough to have a fellowship through the Kenan Fellows program at NC State 2 years ago. And through that program, I did an industry immersion with a local community college here on the coast, where I was able to learn all about the trades that are going to be in high demand in the next several years, with respect to clean energy, renewable resources, all things like that, kind of to broaden the horizons for educators like myself, but most importantly, students who are in middle and high school at this time, because they will be the workforce in the next 5 to 10 years, right? So I worked with the community college in Morehead City, and I learned a lot about the renewable resources that our coastal area has to offer. So that's kind of my background with getting into this sector. And of course, middle school education is integrated all throughout the sciences. So we do a little bit of each topic. And I'm fortunate enough that in 8th grade, which is what I have previously taught, and then also in 6th grade, I've been able to integrate a lot of these renewable lessons into our curriculum. So first of all, we have to think about how we are going to teach these concepts. So you can't just rely on teaching students about the different types of renewable energy, we have to teach them why. And the way that we do that effectively is not by just direct instruction explaining the concepts to them. So if you're not aware, the number of minutes that a child can remain engaged with direct instruction, a good baseline is to be 1 plus whatever their age is. So currently I teach 11 and 12-year-olds. So I assume that they should be able to remain engaged with me for about 12 to 14 minutes. So that's not a lot of time. And so the way that I combat that is by utilizing high engagement strategies like project-based learning, which I'm going to talk about in a little bit. So the way that we do this is we start with why. To a middle schooler or even a high schooler, the concept of the future and what the climate might look like in the future, or what our energy crisis might look like 20 years down the road, that is very abstract, and students need to understand why. And we're going to talk about how we can use this data to not just tell them, but to actually visually show them this is what could happen if we do not come up with strategies to mitigate these energy crisis problems. So starting with why, understanding very early what do my students already know about climate change and the energy crisis, and explain to them why this is important and help them understand that they are going to be part of the future and that they could have an impact on this. So I talked about project-based learning. The reason that I use this is because it is so easy to differentiate the different problems and outcomes for my students. So the way that project-based learning works, or problem-based learning, is you give them a prompt, and these clean energy, renewable resource prompts are very much real world, and connect them with the real world and give them a lot of buy-in and ownership over the science that they are learning. So I just gave 3 examples. Of course, you don't have just 3 levels of learners in your classroom at any given time. You can have so many more and so many other things that you need to differentiate for. However, I just gave 3 examples for advanced, on grade, and below grade students. The problem is meant to be the prompt that they are given. So what is it that you would like for them to solve, or what is it that you would like for them to come up with a solution to? And then possible outcomes. Project-based learning outcomes should be very wide open. As the students engage in this inquiry process, they should come up on their own with what their outcome is going to be. But for some of your learners, that might be too broad for them. So you could give them possible outcomes. And of course, you can differentiate that depending on the level of learner. So that brings us to how we're going to utilize NASA data in this research. So when I present my students with these differentiated problems that they are going to set out to solve, we talk a lot about supporting evidence and modeling what this change can look like in the future. So there are 2 sites that I'm going to talk about: My NASA Data and the GLOBE program. Both are put forth by NASA. And this allows students to investigate real data from NASA and how they can apply that to the problem that they are given in class, or just in general, how it relates to where they are in the world. So, first is my NASA data. So, like I said, this is real data from NASA, gained from satellites, different missions, and research initiatives. And the focus is for students to understand Earth's climate, atmosphere, and environmental changes. And I'm going to show you the different variables that you can change and map the data in a really real and visual way that I think benefits students a lot, because you can talk all day about how different things are changing and how sea levels are changing. And you are only going to reach so many of your students with your words. So this will encompass that visual piece for the visual learners like I am, and they can look at two different maps that are mapping the same variable, one from 25 years ago and one from this year. So I think that is a really powerful set of data for a student to look at. So, this website also offers a lot of educational resources for teachers. They have lesson plans, they have links to high quality, reliable videos that have been vetted by NASA. So, it's not just going to YouTube and typing in the topic and hoping for the best. It is educational resources that have been curated for educators specifically for this reason. Also, I'm going to talk about hands-on learning opportunities when we talk about the GLOBE program. So I'm going to skip over that right now. Interdisciplinary connections. Obviously, you're looking at a map, you are going to have to talk about geography. You're talking about various data sets and variables. You are going to integrate mathematics and statistics into these. Of course, you can differentiate this, level it down for sixth graders like I have done, or I've also used the same data sets with my eighth graders. And for any level of student, you can talk about this data. Depending on how you approach it is how it will be absorbed by them. So I really like that you can use it for a bunch of different levels of learners. Also, global context and collaboration. Again, I'm going to talk a little bit more about this with the GLOBE program, but I think that it is very valuable for students to see that not only is my immediate area being affected, but on a global scale, things are changing, and what will this look like in the future? A lot of our students in middle and high school haven't had the opportunity to live in various places around the world, so it is good to give them some context and some collaboration with other areas that are providing data. And then inspiration for future careers. They have a lot of information. I'm going to go to the next slide to talk about this on the CNRM future climate modeling. And if you're not familiar with that, that's a meteorology research study out of France, I believe. And they are climate modeling for what mitigation could look like for the climate in the future, or what it could look like if we continue the way that we are. And then I just put a list of other things that my NASA data provides for educators on the side of this slide. So I'm gonna show you the website. So this is my NASA data. It's divided into the spheres. Visualized data is where you are going to be able to access the Earth System Data Explorer, which is the map that I showed you. Over here, you have data set selection, so you can choose what it is that you would like to look at. So, for example, we could look at greenhouse gases, and let's look at the water vapor in the atmosphere, and then you can select the year and month that you would like to look at. So using this tool, it is a really good example of how students can compare past data with more current data, and what things might look like in the future. So going back to their problem or project-based learning, they can use this information as supporting evidence for, here is the problem that I have been faced with, here's my solution, and here are all of the reasons that this is going to be beneficial in the future. Because if we continue the way that we are, then these are the potential impacts that we could have. So that gives real time data from NASA for students to use, which is just an invaluable, reliable resource for them to look at. Okay. I put this on here because I did not want to forget to show you, if you are specifically talking about Earth's energy budget and the renewable resources, this, if you go to Earth as a System and Earth's energy budget on their website, it will give you pages and pages of resources, and I'm hoping that you're all going to go look at it for yourselves. So I'm not going to go there for you because it is a lot to digest. There are webinars, resources for educators, videos that you can show your classes, texts, and leveled information that you can use. So it is a really good place to look if you are thinking, okay, I want to talk about the energy crisis and I want to talk about renewable energy. Where do I start? This is a great place to start with my NASA data. This is some examples of what you can find when you go through the Earth's energy budget tab on my NASA data. This takes me to the directly to the EPA website and gives me different information about ocean heat and climate change indicators, and you can change different variables and generate different charts, which again is very valuable for students to learn how to read these graphs and interpret this data. Okay, so moving on to the GLOBE program. This is the Global Learning and Observations to Benefit the Environment. And it is a really cool citizen science program where students from all over the world provide data to this mass collection of information, and that allows anybody who signs up for a Globe account. You do have to sign up for an account, but it is free. You can access all of these data sets and interpret it in various ways. So this is the global context piece for me, because students want to learn from other students. I think that they are their best resource when they're in the classroom or when they're out of the classroom. They love to talk to each other and they love to hear other students' information about topics that they're interested in. So what this does is it's a platform that allows for different classrooms to input climate data for their area, and then you can look at it with your class and say, oh, this is from this school in this area of this country, and this is the data that they collected at that time. So it gives them that global context piece. It lets them collaborate not only amongst themselves in their classroom, but they're collaborating with hundreds of other schools around the entire world. This can be very hands-on. I'm going to show you how they can collect data in a short video that I made. So they can make their own observations and provide that information to the GLOBE program, which is extremely hands-on. They're learning about the climate around them and how to disseminate that information in a way that's going to be usable for other people. Again, with the project-based learning, the students are going to be able to utilize this data from other places to be able to solve the problem that they were originally given.
Teachers, did you know?
Oh, let me go back.
Teachers, did you know that?
Okay, so I made this little video.
Teachers, did you?
Okay, it keeps playing. I made this little video. You can download an app. This is kind of challenging depending on your school's cell phone policy. However, if you have a club outside of school, or if your school allows cell phones for education purposes, or if your students have a device that has a camera on it, like a computer or a iPad with a webcam, they can take data measurements with their device and contribute to this this collection of data. So I'm gonna play the video and then I can talk about it after.
You know that you and your students can collect real data for NASA? Through the Globe Observer app, you can record cloud observation data at your location. You answer some questions about what the sky looks like around you, as well as the current surface conditions. Next, it will guide you through photographing the cloud and sky conditions in each direction at your current location. The coolest thing is that after you submit your observations, you can see what other citizen scientists have observed today around the world, including their photos. I hope this helps.
Okay, so you kind of saw the map on there and where it will map the other information. When you sign up for a Globe data collection account and you start collecting data, it sends it up to NASA, and it is approved based on the collection that you made. And then you get information back that is about the data that has been collected in your area or around the world at the same time. So it is really just a great resource to let students see that they can collect this real data that is actually being used by other schools and NASA and other entities. So it really gives them a sense of ownership in the climate and environment space, and that sense of ownership is enough for them to get excited about learning more about how to make more sustainable choices in regard to energy. So this map is an example of the visualization system on the Globe's website. These dots are all data collection spots, and I think this is just really cool to see that all of these citizen scientists in classrooms and office buildings and anywhere around the world are going outside and collecting information about the world around them for the benefit of everybody. Okay, so why are we going to use all this data in these resources for PBL? We are utilizing real data to, most importantly, enhance this learning experience for students. Students want to have ownership in what they are learning. They need to have buy-in. They have to have why. Why am I learning this? Why does it matter to me? Otherwise, you start talking about all of these big words in renewable energy, and they stop listening if you are trying to use direct instruction. They need to be out there and learning it themselves. So it's going to enhance their learning experience. It is going to let them see what the global challenges are that the world is facing and that we stand to face in the future. So it gives them this context of your environment is not just where you are. This environment is everyone's responsibility. They're going to gain a deeper understanding about climate change and energy production. and it will encourage them to think critically, creatively, and collaboratively with others all over the world. Of course, the hands-on learning and data analysis is so easy with this information. There's no way that us classroom educators would be able to go and collect all this data and compile it into such a rich visual experience for the students. So that's all that I have. Does anyone have any questions?
Savannah, thanks for sharing that with us. That's really impressive. I
Yeah.
wasn't previously familiar with those tools, and I think the mapping function with the visualization was really amazing. I wish they had something like that when I was in middle school. That would have probably increased my interest in my earth science class.
Yeah, and I think that it's really important to understand that because I am not really big on students using devices in class all the time, but if you can utilize them in a way that is beneficial and very intentional, like in this way, I mean, it can be just an amazing resource for students who are visual learners.
So we've got a couple questions that I'll give you to address. I think a few people mentioned there's a lot of changes in federal government right now, and maybe some question as to what the future of NASA might be, and whether or not data sets like this will still be a thing on U.S. government web pages, or if it might disappear at some point or be deleted. Do you know, is this data being preserved by any other organization, or is it possible for teachers to download the data sets that they're interested in? So if they go to the time of creating a lesson today, they can be assured that next semester they're still able to deliver it?
Yes, so especially on the Globe program website, that is only sponsored in part by NASA. So um, to your first question about is it being preserved somewhere else, I am not sure. However, you can download it. I have downloaded several data sets as Excel files. And as you can see, I just go ahead and take a screenshot of a map if I am interested in that specific variable that we're looking at. So yeah, you can download data sets. I hope it's being preserved somewhere else. I know there's a lot of uncertainty, but I think that maybe the saving grace will be that it is primarily a citizen science initiative, and it's people who are just making observations about the world around them. So hopefully it won't go away.
So, sort of related question, and you touched on this a little bit. I'm curious if you can tell us a little bit more about like the ability to download the data and manipulate it. Whether you could get it as like a .csv file or something that could be put into Excel, or better yet, I'm thinking like for older students, is it the sort of thing that you could import into like SAS or SysStat, where students could then, engage doing statistical analysis with some of this or trend analysis? And are there lessons that the NASA community has maybe developed to support that?
I have not looked into the lesson creation for that level of learners. However, you can download the data and interpret it just as an Excel document. And I have had students download data and then I've showed them how to generate their own graphs. So that has been a really cool resource for my middle schoolers. Um, but yeah, does that answer your question?
Oh, it totally does, because like every student that's going into engineering has to kind of become a master of spreadsheets, right? So this is a great way to take a real world data set, and you're still teaching all those fundamentals of how to manipulate data, how to work with data, how to generate plots, do trend analysis. But instead of doing it with a, make-believe fabricated set of numbers, you can actually be using real world data. And it sounds like these data sets are pretty large too, which you don't always get with a fabricated data set.
Yeah, I was trying to figure out a way to screenshot a data set and put it on to one of the slides, but the information is just so massive that you just have to go in and play with it yourself. And it takes maybe 5 minutes to sign up for a Globe account. If you download the app on a device like your iPad or your phone because you want to take the data analysis, it does take a little bit longer. But for just accessing those data sets, it just takes a couple minutes to sign up with your email.
So maybe just to give us a sense, if we were to download one of those Excel files, how many columns, how many rows would we expect to see in one of those files?
Hundreds, hundreds of rows. The one I downloaded that I was trying to figure out how to put into my slide, the first column is what school collected, or what entity, they're mainly schools, collected that data point. And I mean, it's just so many schools. It is overwhelming the number of students that are engaging in this content.
So that seems to me, a good exercise for some of us to, give students that giant file, and then they have to go through the process of learning how to filter and sort the data, right? Which is a skill every engineer needs to have.
Yes.
And I can imagine for younger students, maybe the teacher goes through and sort of redacts the set a little bit for them before, dumping all of that in their laps and leaving their students overwhelmed.
Yes, definitely.
Let's see. I had another question here as well. Well, another observation. Just noted that the time on task equals the age plus one. I hadn't seen that previously, but I think it's a good metric for us. So, have you found that to be pretty accurate with your own students?
Yes, especially with middle schoolers. And that is the upper end of the number of minutes that they can stay engaged. So if I know that I have something that is a concept that they're going to need direct instruction on, and it might take me longer than 10 minutes, I have to break it into different parts so that they are able to receive the direct instruction, then do something, manipulate something, then go back, receive a little bit more direct instruction, because once I learned the number of minutes that students can stay engaged with me just talking to them, and I started implementing that in my classroom, students, I mean, my behavior management was so much easier, because when students are engaged and then they know I better get this done because my direct instruction is going to come back in a couple minutes. um I mean, it's great, and they are listening to what you are saying. They are internalizing it. Not all of them, but just breaking it into those smaller portions and then allowing for them to do the learning on their own. It has just been so much easier to get them to engage with these more difficult scientific concepts that maybe might be more abstract for a sixth grader.
So kind of related to that, maybe you could just kind of walk us through a little bit of like what the data collection looks like with your students. Like how much time do you give them? Do you have to schedule a special field trip to go to a location? Do they just walk outside the classroom and do it right outside the building? Um, maybe you can shed a little light on that for us.
Yeah, so in our district, we have a no cell phone policy. So the data that we collect, I have created paper pencil data sheets that they will collect. And I did this more with eighth grade. So going outside and making observations, of course, they have to know the vocabulary words. What am I looking at? What is this called in the sky? Different types of clouds and things like that. So they would make the observation pencil paper, and then we would collectively decide what data we were going to collaboratively input into the system. So I would input one data point for 100 observations.
Yeah.
But that's what it looked like here. I think that if you were to have students that were able to have their own devices, that would be even more powerful for them because they would have to physically go through and make those observations. It's just not feasible, especially for middle schoolers. I can't see 30 phone screens at one time. So it's just easier to do it paper pencil and then go back in, collaborate. Okay, what did we all see? And how could we say this in a way that serves all of our observations?
So just thinking a little bit, for older students, high school or community college, they're all going to have a smartphone in their pocket. How long does it take to generate a set of measurements and enter a report for a student like that? Are we talking 5 minutes, 10 minutes, 15?
Yeah, probably 5 or 10 minutes. And like it showed in the video that I made, you can't mess it up. There's a circle that says south on it, so you face your phone south and you line up the circles. I mean, it's fairly simple. Like I said, as long as the student or the scientist understands what the vocabulary words are and what it is that they are inputting, because you do have to answer questions that are specific to what it is that you are looking at. There are some pictures for some of the different types of clouds, but it is beneficial to have that background information to know what it is that you are doing.
And then a question about how the locations are recorded for the sites. Are these recorded as like city and states, or are students entering latitude, longitude numbers, or does the phone just grab a GPS coordinate?
The phone grabs latitude and longitude.
Okay. And
Yes.
so if we downloaded the file, we'd see those lat and longitude coordinates as two columns in the spreadsheet then as well.
Yes, sir.
Oh, that's great for earth science class. Everybody has to learn those measurements. So.
Yes.
And somebody who was asking that would be decimal degrees, right, for latitude and longitude, I presume.
Yes.
Okay. Very nice. Well, I'm just kind of glancing through the chat box here to see if we had any other questions that I maybe have missed. I'm in my 50s now, so if I add one to that, that means we have to keep this webinar under an hour. Which we do with all our webinars. So, well, Tiffany, I think we've gotten through all of our questions. Thank you so much for sharing this with us. I'm really curious to see, as I understand, you are finishing up a master's degree project. Will this form part of your thesis?
This will not. A lot of my research that I've been doing is related to teacher retention and more like teacher preparation. So yeah, I'm interested to see how the project-based learning and how engaging students can change the way that teachers look at education.
Well, when you have your results and you finish writing all that up, we'll look forward to seeing the publication that comes out of it.
Yeah, definitely.
Well, thank you very much, and for the folks on the call today and the folks viewing the webinar, we hope you'll join us again on another Create webinar presentation. We've got a few more scheduled between now and the end of the semester, and we wish everybody a good afternoon.
Thank you. Great job.
Thank you. Very nice.
Thank you.